Science fiction under most circumstances across its history tends to not use real place names. Authors tended to make something up, like a galaxy far, far away, to free themselves of getting pinned down on the realities of actual exoplanetary systems, which could get a writer bogged down and detracting from the story. But there are instances in science fiction where real, actual star systems are invoked as to where a story takes place or is related to it. Here I thought it might be fun to explore some of those settings from famous science fiction, and then see what those star systems are really like. There is one star system that should be mentioned that I think will appear in science fiction in the future more than it currently has. It's there in sci-fi history and features in the Halo universe, Asimov's Foundation trilogy, Babylon 5, Alistair Reynolds' Revelation Space, the Babaverse series, and others, but not as extensively as other known stars that really exist. I think there's still more room for this system to feature in science fiction. It is the Epsilon Eridani star system in the constellation Eridanus, a southern sky constellation visible from most of Earth, and it's a star that is bright enough to have an actual name, Ran. This star is only 10.5 light-years distant and is visible to the naked eye. This star is young, only about 1 billion years old, and is an intriguing type of star. It's a Type K orange dwarf, and these are mysterious in regards to Ceti and alien life, so much so that it was one of the earliest Ceti targets, along with Tau Ceti, that Frank Drake looked at in radio as part of his Project Ozma. So out of the stars that we normally think of as habitable, at least in the sense we have of that right now, you have red dwarfs, orange dwarfs, and yellow dwarfs, such as our own sun. It's not actually a dwarf and it's not yellow, but we all know the problems with how astronomers name things. You also have Type F, which are marginally habitable, but really heavy on ultraviolet emissions. The red dwarfs, when they are young, tend to be problematic. They flare and are rather violent for being little guys. They're called Type M stars. Our sun is a Type G, and we obviously know that this type of star can support life or we wouldn't be here. But the thing is, the sun is not a perfect star to be located around. It has a limited lifespan compared to red and orange dwarfs, way limited. And in fact, the most ideal stars for life seem to be the orange dwarfs, like Epsilon Eridani. As an aside, this invokes a variation of the red sun paradox. This is a relatively new development in the question of the Fermi paradox, and was formulated by none other than David Kipping of Columbia University, whom many of you will be familiar with as a YouTuber. It's simply the question that since red dwarfs are vastly more numerous than stars like the sun, then why aren't we located around a red dwarf? The answer may be so simple as red dwarfs not being particularly suitable for intelligent life, but the same also goes for orange dwarfs to a degree. There, the paradox may be deeper, since, as far as we know, they appear perfect for life, and are something on the order of twice as plentiful as Type G stars. That's a mystery. Epsilon Eridani does have its specific problems, however. It's a young star, and that means it has higher levels of magnetic activity, and a really powerful stellar wind coming off it, way more than our middle-aged sun. It's also somewhat metal-poor, lower than the sun again, which is odd because younger stars tend to be metal-rich. So what might be happening is that all of the heavier elements convected deep into the star and cannot be seen. One interesting thing is that it's actually part of a group of stars known as the Ursa Major group, which all share a common motion through the galaxy, suggesting they all formed in a common cluster, a nebula, and are still dispersing. But the thing is, even though it's poor in heavier elements compared to the sun, there is evidence of a giant planet orbiting it, basically a Jupiter analog. It has no other confirmed planets, but very well may have them, even terrestrial ones. This giant planet was controversial in that it was detected through radial velocity, the gravitational wobbling of a star that has a planet tugging on it. Interestingly, there have been observations done with the James Webb Telescope to try to directly image this giant planet. Those results, as of right now, have not been released. If successful, though, expect this star system to be in the astronomy news soon. The system also has a debris disk and there is a gap in it, which suggests that there are outer planets shepherding the disk. Ceti has looked at this star just in case, and no indications have come from it. It does not show evidence that we can detect of being an abode of life that emits things like radio signals. But it's a young system, so it really isn't somewhere you would expect that unless someone from somewhere else had colonized it. But if someone out there wanted a setting for an interesting star system that a civilization had colonized or Earth colonized, this might be a good choice from a hard science fiction point of view. If there were anyone at Epsilon Eridani that could see the stars in the night sky, the sun would be a relatively bright magnitude 2.4 star in the constellation of Serpens. They could visually see our sun if they had eyes like ours. It wouldn't be the brightest star they could see, but it would be a dot out there visible to the naked eye if a human were out there looking back at home. There's something poetic about that. The next star is also in the constellation of Eridanus, and it's well known in science fiction. It's 40 Eridani, and it's 16.3 light years from the sun, and it's also visible to the naked eye from Earth. Its primary star is known as Kaid, and it has a binary pair of stars orbiting it. Any planet here would have 3 suns, like Tatooine, but with an extra star. But the view wouldn't be anywhere near as dramatic as Tatooine, in that one of the members of the system is a white dwarf, indeed the first one ever discovered, and the other is a dim red dwarf. They would just look like very bright stars from a planet orbiting the main orange dwarf in the system. The main star is another Type K orange dwarf, and the final star is a red dwarf that flares heavily. It's not clear what type of star the white dwarf was before it shed its outer layers, but most likely was significantly more massive than a sun. This makes that particular member of the system unlikely to currently host life because a giant star evolving into a white dwarf is a rough process, and probably would have sterilized anything in orbit of it. That is a star to look for fossils of an extinction event, should there be anything there rather than existing life. The red dwarf is probably bad news because of its very active flaring, so the orange dwarf is the place to be in 40 Eridani. The habitable zone of an orange dwarf is closer in than a Type G star like the Sun, so if you were on a habitable planet around the dwarf, it would appear significantly, about 20%, larger than our Sun appears to us. There are radial velocity hints for the main star to have planets, however. They've just been difficult to confirm because stellar activity can mimic radial velocity in a case like the star. Again, from the vantage point of this star system, the Sun would be a moderately bright star in the night sky in the constellation Hercules. And now to the appearances in science fiction. It's a big one on that count. 40 Eridani A, the orange dwarf, figures prominently in the Star Trek universe. It is the home of the planet Vulcan. Spock aside, in the Babaverse, it also names a hypothetical double planet, Vulcan and Romulus. It also features in the Dune universe. Much more recently, however, is Project Hail Mary by Andy Weir, a great book made into an excellent film. And again, the orange dwarf here is home to the planet Erid, where Rocky is from. Read the book, see the movie, because it's really good. Fun sci-fi like that is hard to come by these days. The next star is also prominent in Star Trek, but also featured in an Outer Limits episode from the 60s. In Star Trek, it was the location of a famous battle between the Federation and the Borg Collective that did not end well for the Federation. But the real star is a red dwarf in the constellation Leo, just under 8 light years away, and is not visible to the naked eye. This star is really tiny, and in fact its photosphere is cool enough for chemical compounds to form. Things like water and titanium oxide have been seen in its spectrum. This star, of course, is Wolf 359. It's magnetically very active and it's a nightmare on the red dwarf flaring. It has a candidate exoplanet but nothing verified. This is not likely a system for habitable planets for life, and the star is still relatively young, less than 1 billion years old. If you were in this star system on a habitable zone planet, the star would be closer to the moon in brightness than it is to the sun. This is a very dim star, near the very lowest limit for a star, not much larger than a brown dwarf. While not great for life right now, this star will remain more or less in its current state for 8 trillion years, so maybe something will happen in the future. But as a place for a battle with the Borg, it would still be able to do that. The Alpha Centauri system also appears in sci-fi, but not as much as you might think it would, being the closest star system to us. Two early ones from 1931 and 1935 respectively are a short story from Leslie Stone titled Across the Void, and a short story by Murray Leinster titled Proxima Centauri. A.E. Van Vogt used it as a destination in the novel Far Centaurus and others, but perhaps its most well-known modern mention is in The Three-Body Problem by Liu Cixin. Alpha Centauri is a system of 3 stars: Rigel Kentaurus, which is a Type G Sun analog, Ptolemon, which is an orange dwarf, and Proxima Centauri, which is a red dwarf. This system covers a lot of bases, and is the most conveniently placed star system currently for us to go visit. There are known planets around these stars, particularly Proxima Centauri, and hints of others. But what they are actually like is an open question, but the possibilities are pretty heavy for this star system as far as life. But again, no signals have ever been received from the star system that were conclusively of alien origin. The next star is Tau Ceti, the second star Frank Drake looked at with a radio telescope for signals early in Ceti. Tau Ceti is very much like the Sun, a Type G, but only about 78% of the Sun's mass. Located just under 12 light years away, and what's noteworthy about the star is that it appears to be really stable. Stable is good. The star is deficient in metals, and like the other entries on this list, the Sun would be a bright night sky star if you were in this system. Tau Ceti is weird. It shows low metallicity, which means that this star is old, older than the Sun. But this is a very dusty star system, about 10 times more than the Sun. That's sort of contradictory for some reason, since star systems tend to lose their debris disks over time, and the dust thins out. For whatever reason, that did not happen here. And while no unambiguous evidence of exoplanets in the system is surfaced, the fact is, anything there would be getting impacted far more by meteorites and asteroids than our solar system is right now. Evolution probably would have taken a very dramatic deviation in this system than what happened on Earth. We had the occasional large asteroid changing the equation, such as with the extinction of the dinosaurs, but Tau Ceti would see that much, much more frequently. Tau Ceti features also in Project Hail Mary as the destination point, the main setting of the story in both the book and the film. And this system is also the source of the problem that needs to be solved in that story. Other authors that have used this star as a setting include Larry Niven, Ursula Le Guin, and Kim Stanley Robinson mentions it in Aurora. The final star for this video is perhaps the most spooky. It's the Zeta Reticuli system. This system features prominently in sci-fi as having some kind of link to the xenomorph of the Alien franchise. The moon LV-426, also called Acheron, was fictionally located in this system, and was where the crew of the Nostromo found the so-called space jockey, seemingly fossilized and having been killed by something that came from within it and burst out. They then find the xenomorph eggs, and so begins the franchise. The inspiration for that screenplay was probably taken from the infamous Betty and Barney Hill UFO abduction claim. Betty Hill claimed to have been shown a star map by an alien species, most often identified as the Greys, that she committed a memory and was initially thought to coincide with the Zeta Reticuli system, but it actually doesn't. This then made its way into the UFO lore. But the real system is interesting. It's a wide binary star system of 2 sun analogs, both Type G, about 39.3 light years distant. They are both very close to the Sun's mass, over 90%. They are metal-poor stars, so might be old, but maybe not. There are some indications that they could be as young as 2 billion years old, but the age here isn't well constrained. For some reason, Zeta Reticuli 1 has a very low abundance of beryllium for unknown reasons. But this system has never shown any indications of planets, and it's certainly been looked at for signs of it, nor have any radio signals ever been detected from it of SETI interest. But then, one has to say, the xenomorph isn't exactly the most likely creature from science fiction to be sending out radio signals. Even if they could, which they were depicted as smart but pretty primal, one does not radio their prey before they strike. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently eyeing Ridley Scott suspiciously. One of the really interesting and extremely spooky aspects of the original Alien movie was finding the space jockey. I absolutely love that sequence in that movie. There was this whole aura of mystery and unanswered questions that made the whole thing extra spooky. But in later lore, they explained how the sausage is made and took the story in the direction of the engineers. I would not have done that. Some things are best left mysterious, and I think there really was no reason to go there. Make the engineers someone else, not the ancient fossilized space jockey of mystery. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.